For a century, maps showed an island in the Pacific Ocean. Then scientists went looking for it and found nothing. This was Sandy Island. The coordinates placed it in the Coral Sea, sitting midway between the eastern coast of Australia and the French-governed territory of New Caledonia. It enjoyed immense credibility, appearing in international maritime charts, National Geographic atlases, and most notably as a dark, solid polygon on Google Earth. When a feature is hard-coded into modern scientific databases, we assume it has been verified. We trust that the pixels on our screens correspond to physical reality. In 2012, geologists aboard the research vessel Southern Surveyor were conducting a study on plate tectonics. Their planned route passed directly through the center of Sandy Island. The captain approached the coordinates with extreme caution. The charts indicated a landmass 15 miles long, suggesting reefs shallow enough to destroy a ship's hull. Instead of land, the crew found only open ocean. The ship's sonar registered a depth of 1,400 meters, proving there was no island, no reef, and no sandbar at the coordinates. A group of ham radio operators had actually reported this anomaly in the year 2000, but it took the 2012 sonar readings from a scientific vessel to finally confirm the absence to the world. The expedition confirmed that the world's most trusted maps were displaying a lie, triggering a forensic investigation into how a ghost island survived for over a century. The paper trail leads back to 1876. A British Admiralty chart included the island based on a single report from a whaling ship named the Velocity. In their journals, the crew of the Velocity didn't describe a stable island. They recorded seeing heavy breakers and sandy islets. Geologists believe the sailors likely spotted a pumice raft. Massive underwater volcanic eruptions can create floating rock formations miles long that, from a distance, perfectly mimic sandy landmasses. Early cartographers simply copied the Velocity's report onto official charts to warn other ships of potential hazards. Through decades of repetition, the observation of a temporary floating hazard was transformed into a permanent physical landmass. This creates a central paradox. French and Australian hydrographers actually deleted Sandy Island from their paper charts in the 1970s and 80s, yet decades later, it remained on Google Earth. The error survived through the World Vector Shoreline Database, a massive digitization effort that converted old paper maps into the foundational data for modern digital mapping. This database used a landmask, a digital filter telling algorithms where land should be. This programming flaw blinded the satellites. Because the database claimed land existed, algorithms ignored real sea surface temperature data, rendering a black void instead of the ocean. This sonar data and depth profile finally broke the illusion. The blue values prove the ocean floor sits thousands of meters below where the database incorrectly mapped land. Advanced technology failed to correct the mistake. Instead, the algorithms automated the 19th century error, amplifying it to a global scale. Sandy Island is part of a grand cartographic tradition known as phantom islands. These ghosts appear when mapmakers record optical mirages, chart reefs that have since subsided, or even draw intentional copyright traps to catch plagiarists. Sandy Island represents the modern climax of this tradition, a place where our collective assumptions and errors finally hit the limits of physical reality. The case proves that our maps are visual representations of information, not the physical reality itself. It underscores the necessity of physical exploration, or ground truthing. Even with modern GPS and algorithms, parts of the mapped planet remain unverified. With the digital ghost finally erased from our modern screens, the coordinates now accurately show nothing but miles of water. We are left with the reality that Sandy Island was never there at all.